Hello everyone, my name is Tung from Andes. Today I'm gonna talk about Andes RISC-V CPU. First, I want to introduce about Andes. Andes is a CPU IP provider which has more than 15 years experience in the CPU market. Since we got solid experience in the CPU market, we provide high quality of RISC-V CPU IPs which has good PPA performance and DSP support. We also provide ACE framework that the user can generate the customized instruction for their usage. With ACE framework, the user can just easily create their desired instruction. The framework will take care about CPU integration, generate library for toolchain, and generate library for instruction set simulator. I will talk about more information about ACE framework in the later slide. Here are some highlights of Andes RISC-V CPU IPs. We have a framework called Andes Custom Extension, which can let users to create their customized instruction. Andes is the only RISC-V CPU provider that supports the P extension, and the Andes V5 CPU also supports the V extension. For the caches, we provide complete cache management, and it can be controlled by CSRs. About the local memory, it's capable of copying boot code to local memory when resetting CPU, and it can access up to 32 MB local memory by HB ports. It also supports vectored interrupt and unaligned memory access. It's also with comprehensive debug solutions. This is the highlights of Andes ACE solution applied to TWS platform. In this case, we created 3 critical customized instructions for the noise control algorithm. As you can see, if we run the most complicated noise control algorithm, it will take 10,000 cycles with only RISC-V instructions. With ACE solutions, it only takes 250 cycles, so overall speedup would be 40 times faster. Next, let's take a look into Andes processor lineup. Andes is the company which has solid RISC-V cores IP portfolio for you. It comes into a wide variety of microarchitecture, starting from 22 series, which is 2-stage single issue pipeline, and the 25 series, which is 5-stage single issue pipeline, supports with 32-bit core, and the X stands for 64-bit core. N25F is baseline stage pipeline CPU with 14-point units, and D25F is the 5-stage pipeline with RISC-V P extension, and the NX25F is the 64-bit 5-stage pipeline CPU. A25 and AX25 supports Linux with 14-point unit and DSP, and A25MP and AX25MP supports multi-core system with cache coherence. As for 27 series, the memory bandwidth is 50% better, and the NX27V supports the RISC-V V extension. We will have one webinar dedicated for Andes RISC-V Vector Core introduction. If you are interested in Vector, you can come to Andes official website and check the schedule for the next webinar. So for the 45 series is a 8-stage pipeline dual-issue CPU. Not only the memory bandwidth is 3 times better, but also the frequency is 20% better. Here is the 25 series performance. For apple-to-apple comparison, Andes 25 series has the best core mark and DMIPS. The core mark can reach 3.58 for 32-bit core and 3.53 for 64-bit core. The DMIPS can reach 1.96 for 32-bit core and 2.13 for 64-bit core. For Redstone, we also have better performance over CM7 and CS7. NX25F can reach 1.38 Redstone per megahertz under single precision, which is about 2.6 times better than CM7, and N25F can reach around 1.3 Redstone per megahertz under single precision, which is about 2.5 times better than CS7. Here are some real usages of Andes RISC-V CPU from our customer. Start with single core. 2-to-8 cores, more than 30 cores, even more than 100 cores, not to mention more than 1,000 cores. Right now, 80% of our customers are using 2-to-8 cores, as for 100 and 1,000 cores is applied for AI server. So we have solid experience for multi-core system and many-core systems. Next, let's talk about the 25 series overview. And this is the only RISC-V CPU IP provider for RISC-V extension. We have configurable multiplier and optional branch prediction. For ID cache and local memory, we support optional parity or ECC protection and supports unaligned low store accesses. For bus interface, we support two master ports, one for data and the other for instruction. We provide AHP staff ports for accessing 4K bytes to 32 megabytes local memory address space. Here are some details about 25 series. If you are interested in detail, we can provide you more information after the presentation. And this provides a user-friendly interface for CPU configuration. It helps to tune the design under different performance, power, and area constraints. And whenever you are trying to port your RTO to different technology node, it's easy to change the CPU configuration, whether you want to instantiate floating-point units or you want to choose different bus interface. After you finish all the configuration, just click Generate N25 core and it will generate all the corresponding RTO core for the user. For the CPU subsystem, it's also highly configurable. The AndeShape configuration tool not only lets users to configure the RISC-V core, but also the whole CPU subsystem is configurable for the user. After finish the easy configuration, the user just needs to focus on interface integration like JTAG and on-board protocol. Even to the platform level, we provide the SoC level platform to let the user can do SoC integration easily. In the platform, we provide bus matrix, DMA, direct memory access, and all the general peripheral with APB bus. The user only needs to take care about JTAG interface and interrupt requests for platform level integration. Here is the Speedup with DSP ISA on 25 series. For Cypher, with DSP extension, it would speed up over 14 times faster. As PNET, it can be 7.5 times faster. For the rest of the information, you guys can just refer to this table. Most important thing is AndeShape 25 series with DSP can achieve many complicated algorithms with AndeShape powerful DSP support. So for DSP support, we support RISC-V extension that AndeShape has contributed with. We also support DSP intrinsic functions, which users can use as C-like function without bothering to program in assembly. It is also capable with SIMSYS DSP library API. For DSP instructions, we provide SIMD for 4 8x8 multiplication and 2 16x16 multiplication. For partial SIMD, we support 4 8x8 multiplication with 32 bits accumulation and 2 16x16 multiplication with 32 bits accumulation. Last one is only for RV64. We support 2 32x32 multiplication with 64 bits accumulations. And this has AndeShape and comprehensive design toolkit. We provide AndeShape development board, debugging hardware like AIS Mini Plus and AIS Micro. We support near cycle accurate simulator. It helps users do evaluation easily. We also support QEMU virtual board, AndeSoft software stack, bare metal demo project, FreeRTOS, ThreadX, and more. We also support from the third party like IR, Loudbar, Ultra SoC, etc. For multi-core system, we provide L2 cache can be configured from 0K to 2 megabytes. It also supports I/O coherent slave ports that the user ports their device to L2 cache easily. Each core can have local memory and L1 cache. The local memory in each core has dev ports, which the user can easily manage their instruction or data. Here is the benchmark for AndeShape multi-core system. As you can see, even the system comes to dual-core or quad-core, the core mark can still reach around 3.5 for each core, which means the performance will not drop down for each core in the multi-core system. Next, we are going to introduce about AndeShape ACE framework. First, we have extensible baseline components. Then the user can write their wanted instruction and corresponding RTL. Then define the instruction type. It can be scalar, vector, or whether you want to run in background. Next, set the script and RTL into Copilot. You can think about Copilot as an EDA tool, which is the most important tool in ACE framework. Through the Copilot, it will generate extended RTL, ISS, and library for toolchain. Lastly, Copilot will merge all the files into the baseline components automatically. Also, Copilot is able to generate the cross-checking environment to make sure the RTL and C are in the same behavior. Here is the ACE inner product example. The user can define their data type. In this case, we define custom register and vector custom memory. Then we will define the instruction with operand and latency. Then we will define the RTL for instruction. We also could define instruction behavior for the instruction set simulator. Overall, the customized instruction is speed up over 85 times faster than baseline instruction. ACE also provides the custom ports that the user connect their hardware module to AndeShape CPU core. Here is an example that there are 4 hardware engines connect to AndeShape core. The interface can be fully designed by the user, depends on the hardware interface requirements. Users can define their port name and port type in the ACE script, then the EDA tool Copilot will do connection between user's hardware module and AndeShape CPU core. Then in the application code, it can prepare command that says through custom register and then send command to do other useful work that we can wait for results to be ready and then get the results. Next, let's talk about AndeShape RISC-V efficiency design. Here is an IoT devices scenario. In this timeline, the power consumption of IoT device would go up and down in every different phase, and it supports different low power technologies to achieve energy efficiency. And this microarchitecture is efficient design, so even for some fully operational cases, that core will not consume too much power. For the periodic services, for example, touch panel, the AndeShape power break technology will stall the pipe when the service is not running. For idle loop, our designs are all clock gated. And when the core logic power off, because in cache design we have put 30 bits into SRAM, so the core can be fully powered down and just need to do SRAM retention. AndeShape IDE has comprehensive feature, library, and all the debug and analysis tool for the user. With AndeShape IDE, the user can easily bring up their project. The GUI is Eclipse-based, and we provide project setup like linker script editor and Flash ISP. And for program analysis, we provide function profiling, performance meter, and code coverage, even function code size and stack size. We have put more than 15 years efforts to improve the IDE tool for the user experience. All the interfaces are easy to use and highly efficient. For bare metal support, we have reached startup demo project for AndeShape specific features like Pleek, Sleek, MMU, PMP, Power Break, Stack Safe, DSP, and more. For a peripheral, we provide all the different drivers for the user, like UART, GPIO, RTC, PWM, I2C, and Watchdog, so it's easy to use and easily to catch up. For RTOS support, we have support FreeRTOS, for 32 bits and 64 bits, and ThreadX is also supports both 32 and 64 bits. And for the FreeRTOS support version, we are now supporting version 10.0, and our FreeRTOS is test switch verified, and we support the FreeRTOS version 10.0 in AE350 platform, and it's a tickless idle, which can reduce power consumption by stopping periodic tick interrupt in the idle mode, and it's based on RISC-V standard M-time and M-time camp. For auto awareness debugging, we support dollar bars /32. For the Linux supports, we support Linux distribution like Fedora, OpenWRT, and Linux kernel tool. We support STRESS, FTRESS, and all the power management like suspend to RAM and power break. And the kernel module supports all relocation types from RV32 and RV64. And as I mentioned, the development tool, we support loader bars /32. For the open source contributions, some as maintainer and some of our major contributors like GCC, LLVM, debugging tools like GDB, OpenOCD, Linux, and U-Boots. So why AndeShape for RISC-V? AndeShape is a leading commercial RISC-V CPU company, and we are an IPO company with 15 years history. We have more than 350 customers in the worldwide and shipping more than 5 billion record. We have professional FAE team and support team. We have better code size and performance and mature tool. So AndeShape of course is your trusted RISC-V CPU vendor. Thank you.